Hoods on conventionals are one model truck item where the kit part is actually very close to its real-life counterpart, being typically a one-piece molding, in this case injection molded styrene rather than fiberglass. Comparing the underside of this kit Transtar 4300 hood to its real-life counterpart shows a few details we can create to make our model an even closer replica of the real thing. Visible here are reinforcing ribs, a bracket for the hood stop spring, and a line of bolts showing where the inner fender has been removed. Looking at underside of kit hood from top to bottom, I'm going to fill the holes for the pull handle because the real truck has a different style than the kit part. Part number 168 is cast into the hood's underside, and two large round ejector pin marks appear near the back edge. I'm going to rework the hinges on the hood to make it easy to remove and reinstall for test fitting purposes, so I don't have to snap it into place as per the instruction sheet. In an interesting little piece of kit trivia, part number 161 on the instruction sheet doesn't match the kit part number, but it is the correct number for the original issue, F4270, when the kit was first released way back in the early 70s. Hood hinge pins and the triangular piece molded on the back side of the hood, marked in red here, will be removed. As shown here, the holes for the hood pull handle have also been filled, and two styrene discs have been cut to fill in the ejector pin marks. Some attention with sandpaper deals with the ejector pin marks, raised lettering, and any of the cut-off parts. The issue now is that the underside of the hood is actually too smooth. Real fiberglass hoods have a noticeably rough finish on their inner surfaces, and to replicate this, a technique used in the armour modeling community to replicate cast texture is being employed here. Lightly drag a carbide burr and a motor tool across the surface of the plastic. I'm using a 7/32 diameter burr here, and I'll use a 3/32 one to get into some of the tighter corners. With fiberglass texture created, installation of the reinforcing ribs begins. I'm going to build these up using 3 layers of 015 by 100th thou wide styrene strip because it's easier to bend the individual thinner strips around the curve than one thick piece. 3 layers in place for the back rib. Some excess styrene does squeeze out between the layers when you're clamping it down. This can easily be cleaned up after the glue is cured thoroughly. Forward rib is now installed, and the ends have been sanded to a slight taper. A closer view shows how sanding makes the 3 laminated strips look like one continuous piece, which on the real hood are molded into the fiberglass to give it additional strength. One part that's not provided in the Transtar kit is the inner fender. Other model truck kits that do not have this part are AMT's Kenworth Conventionals and the Ford Lousiville, while their GMC General and Chevy Bison kits do include an inner fender, and so does their Mack R. This one is sharing workbench base with the Transtar and has had the fiberglass texture added to the underside of the hood, and ribs are in the process of being installed with the first layer laid down as seen here. Inner fenders for the Transtar start with strips cut from 20 thou styrene sheet and tapered to fit the inner contour of the fender. Glue these in place and leave the excess length projecting for now. It can be trimmed off later. Tamiya's quick setting formulation of their extra thin liquid cement works very well for working these pieces into place and securing them. Trace the outline of these newly installed pieces onto 20 thou styrene sheet. From this sheet, cut 2 pieces approximately 80 thousandths of an inch wide, which will be curved in contour, and will be the flanges that bolt the inner fender to the hood assembly. Styrene disc washers and bolt head castings add fastener detail. Glue these in place and then add additional pieces of 20 thou styrene sheet to form the inner wall of the fender. Styrene strip can be laid along the inside of the corner to reinforce the joint. A fair amount of solvent cement will be used here, so let everything cure thoroughly before sanding the corners for a rounded appearance. This inner fender is a more simplified version than on the real truck, but it's effective enough for model purposes. Closer view of inner fender's rounded corner and the row of simulated bolts where it attaches to the hood. To reinforce the connection where pull handle bolts onto the hood, a short piece of flat bar is provided, which acts as a large washer to distribute the force. Model this with 015 styrene strip, 60,007 inch wide, and drill 2 holes for 20 thou diameter styrene rod, which will represent the bolts. Styrene rod bolts, cut extra long, set in place, and pushed into place at the required depth with a setting tool made from a piece of styrene parts runner with appropriate size strips glued to the end. In this case, I used 2 pieces of 30 by 30 square strip to get 30 thou projection. Excess length on the outside will be trimmed off and the holes filled and smoothed along with the original holes for the hood handle. At the top of the hood, there's 4 fasteners molded on either side, and these represent the attachment points for the hood stop brackets. These are made from 80 thou styrene angle, cut 80,007 inch long, and drilled for 032 brass wire pins. Using short pieces of brass wire with aluminum tube spacers ensures alignment, and the pencil marks are the locations of the fasteners transferred from the other side of the hood. Micromark O-scale decal rivets, applied in pairs, simulate the fasteners on the inside of the hood, securing the brackets in place. Now it's just a matter of creating a hood hinge that will allow removal and reinstallation and not have to snap pins in place onto the frame. As a starting point, here's a look at the hood hinge on a real Transtar 4300. I removed the molded-in bosses from the frame on my model, and in hindsight, I could have left them on there and worked with them. One benefit of removing the bosses was that it made it much easier to fill this large hollow area on the left-hand frame rail. It looks like an ejector pin mark, but those are on the inside of the frame rail, so I'm not sure what that depression is the result of. And it's not even a true circle, so I wound up having to use a piece of styrene rod, cut into pie segments, to piece it in, followed by the usual puttying and sanding. This problem only exists on the left side frame rail. On the right side, the circular mark is actually a raised area, which is easily sanded down. Hinge pieces were cut from 332 styrene tube for the hood, and 1/8 styrene tube to go on the frame. Bushings were made from 1/16 thin wall tube, which is a nice fit over 3/64 brass rod, which I use for the hinge bars. 1/16 tube is a slip fit inside the 1/8 styrene tube, so those bushings are glued in place. The 3/32 tube is drilled out 1/16, resulting in a nice press fit for the bushing. 1/8 holes are drilled in the end of the frame rails to receive the frame bushings, and these are glued in place, with styrene strip gussets added. The location of mine is actually not 100% accurate. They're farther back than they are on the real truck. Again, in hindsight, next time I'll use the bosses molded onto the frame and simply drill them out for the bushings. The hood hinge pieces are assembled onto styrene strip, and pieces of 30 thou quarter round are added to bulk up the hinge and add some more gluing surface. One edge of each strip is sanded to match the curved contour of the inside of the hood. Hinges are glued in place on the inside of the hood, using the fasteners molded on the front side as a general guide to placement, and then styrene bolt head castings are added on the inside to represent the fasteners. With the bushings in place on both the hood and the frame, it's time to tape everything together for mock-up purposes and bend up 3/64 brass rod to connect the two pieces. A closer view of the positioning of the two bushings. The 3/64 brass rod will have a 90-degree bend up and a slight forward bend to accommodate the offset. A 90-degree bend is easy. The offset will require some trial and error and test fitting. At this stage, I'm happy with the fit of the hood and the bends on the hinge bars. I now mark each hinge bar right at the edge where it contacts the bushing on the frame and file a small notch at this location for reference. The notch is just visible here. I prefer filing the notch rather than using a marker or a spot of paint because the notch is a permanent mark that can't be rubbed off inadvertently. 1/16 thin wall brass tube sleeves are cut to a suitable length and soldered in place. These will ensure the hinge bar always goes back into the same place when reinstalled, ensuring side-to-side alignment of the hood. The slight offset bends required to set correct hood spacing front to back are also visible, and the red marks are where the excess length will be trimmed off. Completed hinge bars with a section of 1/16 thin wall tube that will go between the frame rails to create the appearance of a continuous bar spanning between the frame rails as shown on the real truck. Here is the model version ready for installation of the hood. The hood can be test fitted as many times as necessary. It simply slips on the vertical pins and is easy to take off. Hood in place and tilted, and supported by a 1/25 scale oil drum because I can't install the hood stop cables yet. Again, on my model, the hinge bushings on the frame are further back than they are on the real truck, and on the next Transtar 4300 I build, I'll use the molded in bosses on the kit frame and simply drill them out to take the brass bushings. Thanks for watching all the way to the end of this very literal interpretation of detailing under the hood. These details are easy to add and do enhance the appearance of your completed rig, especially if you display the model with the hood open.